All right, the final thing we're going to do is we're going to be looking at some of our past problems, and we're going to try to find a pattern or a trick in order to solve for future problems. And what we're going to be discussing really is multiplying two decimal numbers. So in these problems, we actually were for with and without this one and over and under, and also when you guys did the cupcake, what was it, making cupcakes model, what you were doing is obviously you were multiplying decimals, and I'm going to show you what they looked like without these papers. Okay, one of the problems that we had was about Vanessa, and she was making vanilla yogurt cups for $2.50 a cup. She wanted to know how much she was going to raise or make if she sold 19 of them. So it was $2.50 times 19. Well, when you guys did the problem with the ratio tables, we figured out that this was actually $47.50. So we're going to look at this in the partial products or standard algorithm in order to see how we can do this using a different way than ratio tables. So if I write this down, and I'm going to write this because it has 3 digits in it here first, so 250, and I can put my decimal in there, times 19. Now I'm not going to worry about the decimal right now as I'm doing my multiplication problem. But just like before, I'm going to do the standard algorithm because we practiced that last week. So if I do 9 times 0, it's 0. 9 times 5 is 45. I bring the 5 down. I carry the 4. 9 times 2 is 18. And then add 4 more is 22. I cross it off just so I remember. And then I need to add the 0 for my place value because now I'm in the tens. So 1 times 0 is 0. 1 times 5 is 5. And 1 times 2 is 2. Of course, then we add them up. So we have 0, 5 plus 0 is 5, 2 plus 5 is 7, and 2 plus 2 is 4. Now, what I want you guys to look is, what do you notice about these two problems? We still had decimals up here, but we didn't use them yet. And if you look up here, we got this as $47.50. Well, my decimal should go right here. I'm going to tell you the trick. There is a trick when multiplying with standard or using the standard algorithm. It is you count how many decimal places you needed in the problems, in these problems up here. So this one had no decimals. This one had right here, this number had 1, 2 places in the decimal. So you're going to go down here and you would have counted 1, 2 and added your decimal. Let's try another one to see if this, thought or idea still works. Another problem that you've already done in the past with the with or without model or practice sheet was $2.75 times 21. And when we figured that out for Vanessa, it was $57.75. That's what we figured out with our ratio tables. So once again, we're going to try it using the standard algorithm. So $2.75 times 21. So again, 5 times 1 is 5. 1 times 7 is 7. 2 times 1 is 2. Add my 0 for my place. 2 times 5 is 10. Carry my 1. 2 times 7 is 14. Add the 1 is 15. Carry the 1. 2 times 2 is 4. Plus 1 more is 5. Once again, we add. Now, I told you in the last problem, you're going to count how many decimal places are up here. Well, there's none in this number. This one has 1, 2. So I'm going to start here, go 1, 2. My decimal belongs right here. Does this match? Yes, it does. Let's try one more for good measure. All right, the last problem we practiced was the fancy cupcakes cost 85 cents to make, and if we made 21 of them, how much would that cost? So when we did this on our table, our ratio table, we figured it out to be $17.85. So once again, I'm going to rewrite this problem down here. Now, obviously, I'm going to leave this 0 here, but I could just leave the decimal with it. Okay, so again, 1 times 5 is 5. 1 times 8 is 8. 1 times 0 is 0. Do I have to write the 0 in the front? No. I add my place value holder. 2 times 5 is 10. Carry the 1. 2 times 8 is 16. Plus 1 more is 17. And I could put this up here, so 2 times 0 is 0 plus 1 more is 1. Now I add them up, and then I look for the number of decimal placeholders I have. I have 1, 2. So again, 1, 2, and my answer should be $17.85. So now today, let's try this using 2 decimals. That was our goal. So just like we did before, this time I don't have an answer to compare because we know that this system works. So we're going to multiply these 2 numbers together. And the first thing I'm going to do is I am going to multiply them using the standard algorithm since we've been practicing it. So I'm going to rewrite this. So once again, I do 5 times 2 is 10, carry the 1. 3 times 2 is 6, plus 1 more is 7. 2 times 1 is 2. Placeholder. 6 times 5 is 30, carry the 3. 6 times 3 is 18, 19, 20, 21, cross it off, carry the 2. 6 times 1 is 6, 7, 8. Okay, now if I know, or you hopefully will know, 0 times all these numbers is going to be 0. So do I have to actually multiply them? No, because 0 times any number is 0, so I don't have to do that last number. So then I'm going to add them up. And up here, I had 1, 2, 3, 4. I actually had 4 decimal placeholders. So that means I'm going to take my decimal and I need to move it 1, 2, 3, 4. My decimal is going to go all the way over here. So the answer actually is 8,370 10 thousandths, because that is the 10 thousandths place. Remember, this is the 10th, 100th, thousandths, 10 thousandths. So the answer is actually 8,370 10 thousandths. Let's try one more way, just to see if you guys notice that something else. So let's do it. We're going to do that same thing, but we're going to use the area model or the array model. So if I break this number up, this is 1 plus 3/10 plus 5/100, and this is 6/10 plus 2/100. And then just like before, we make our lines where our plus signs are. So we would do the same thing. So 6 times 1 is 6. Now the one thing is you have to do the placeholder every single time. So this is one placeholder, so I need to move my decimal one spot, and it equals 6/10. And we know any number times 1 is the same number, so I actually could just rewrite those. But same thing. So then I have 3 times 6 is 18. So if I write 18 down, but this has one decimal place, this has one decimal place, I need to move my decimal 2 spots, so it's actually going to go right here. This is 3 times 2 is 6, but this has 1. This is 2 decimal spots, so I actually need to move it 1, 2, 3. So my answer is going to be 6 thousandths, and I could add the 0 up in the front because it's always helpful. So then I have 30 over here. This has 2 spots, this has 1, so it's 3 total. So this is going to be, again, 30, or it's actually 3/100ths, but or 30 thousandths, because we don't need that 0 technically in the back. And then 5 times 2 is 10. This has 2 places, this has 2 places, so I need to move it 4 altogether. So this is actually 1,000th or 10 10,000ths. Then same thing, we add all those numbers up. So it would be 6/10. Make sure you line up your decimal spots when you are, or decimal places when you are adding them, or obviously your numbers are going to get really confusing. Okay, so then we add them all together and we get 0, 0, 6, 1, 7, 11, 12, 13, so carry my 1, 8, 0. Now, do I have to put that 0 at the end? Of course I don't. I can say it's 837 thousandths. I do not need to use it because it is a 0 at the end. And we know that the 0 in the front here is just showing though that there's 0 holes. The 0's behind it. I can add a 0, as many zeros as I want at the very end. I can't push them in the middle because it changes my number. So hopefully this will help you when multiplying two decimals together.